dear friends. I'm so thrilled to welcome you to another session on total quality management. I mean, that the TQM. Today, we are gonna diving deeper into three essential concepts that play a crucial and pivotal role in achieving excellence in quality management. I mean, that probabilities, the normal distributions, and the Six Sigma methodology. These aren't just theoretical ideas. They are powerful tools that have transformed how industries analyze, control, and improve their processes. Understanding probabilities uh, allows us to predict outcomes, um, assess variability, and make data-driven decisions. For example, in a manufacturing setting, probabilities help us determine the likelihood that a product meets the required quality standards or falls outside the acceptable range. This knowledge enables us to identify potential issues before they become significant problems. Actually, the normal distribution or the we can say the bill curve that all of us I think saw this kind of curve that it call it bell curve is another cornerstone of quality management. This statistical tool helps us um, evaluate how consistent a process is and whether its output fall within the desired range. Many real-world variables like the weight of a product, the time required for service delivery, sorry, or the diameter of a manufactured component follow a normal distribution. For instance, if you are producing machine parts like bullets, the normal distribution helps ensure their dimensions stay close to target specifications, minimizing variability and ensuring customer satisfaction. So, finally, we will explore Six Sigma, a highly effective methodology for minimizing defects and optimizing processes. Six Sigma doesn't just aim for small improvement. It focuses on achieving near perfection. By reducing variability and eliminating waste, Six Sigma helps businesses enhance efficiency and deliver products and services of unparalleled quality. This methodology has revolutionized industries such as automotive manufacturing, healthcare, and logistics by helping companies meet their goals with precision and reliability. Throughout this session, I will break down this concept with clear examples and practical application to show you how they come together. By the end, you will have a solid understanding of how probabilities, normal distribution, and Six Sigma form the foundation of a robust quality management system. So, let's begin this exciting journey and uncover how these tools can empower us to measure, analyze, and improve the quality of products and services in any industries. Together, we will see how the science of quality management helps us reach new heights of excellence. So, the probability distributions. Probability is a measure of how likely an event is to occur. Simply put, it's a number between 0 and 1 that shows the likelihood of an event happening. For example, when flipping a coin, there are two possible outcomes, heads or tails. The probability of each is 15%. A probability distribution shows how the possible values of a random variable are distributed generally. And there are two types of the probability. Number one is probability mass function. The brief of this is PMF. For discrete variables that we can use this kind of probability. And number two is we can refer to probability density function. The brief of this is PDF. And this kind of probability is used for continuous variables. So at first we are going to talk about the PMF, or as I told you, is probability mass functions. The probability mass functions used for variable with specific separate values like the outcomes of a die or a coin. For example, the probability of each number on a six-sided die means that the 1 over 6. We can say about this example. The example of the PMF, the probability mass function, again, we can suppose you own a chocolate packaging company. The number of chocolates in each packaging is a discrete value, for example 8, 9 or 10 chocolates. PFM is used to evaluate the probability of each outcome. For instance, the probability that a package contains non-chocolate is P x that I said that is equal 9, is total is equal 0.7. If too many packages have fewer than 8 chocolates, the production process needs improvement. Ensure the number of chocolates per package meets customer expectation and quality standards. The next one is PDF, means probability density function. This is used for continuous variable like height or weight. For example, a person's height might range from 150 to 200 centimeters, with probability spread continuously across this range. For example, the example of the PDF or probability density function in quality management, we can say that imagine that you work in a factory or in a plant that produces car pistons. The diameter of the pistons must be between 90 millimeters and 92 millimeters. The distribution of piston diameters is continuous and follows a normal distribution with a mean equal 91 millimeters, and a standard deviation or sigma is equal 0.5 millimeters. Using the PDF or probability density function, you can calculate probability of producing a piston with a diameter within a specific range. For instance, the probability of producing a piston with a diameter between 90.5 and 91.5 millimeters. A low probability in the acceptable range indicates an unstable production processes. So adjustments to machinery or process improvement can enhance the quality. For the probability density function PDF or the probability mass function PMF, we have two actually drawing picture that it's shown you. This is the bar chart for the function probability mass function, because this is the discrete, you know, I said that in this part that the PMF is for discrete variables, you know. So we have some data in this here, and that all of the data is discrete together, but all of the data as a the data that happen for all of them is likelihood together, is equal together. Actual likelihood of the all of them is equal together. And if you can see, if you investigate from this bar chart, you can find that, for example, for the one, imagine that this is the sixth dimension of the die, and actually for the one of them is the for one page is about this number, for 2 is about, all of them is same as, you can see all of them is same as, but they are separate together. Okay, but for the probability density function PFD, this is the continuously, the all of them data is continuous together, is related together, you know, is continuous together. So this is the curve for the probability density function, that is the like bell curve, you know. So the normal distribution, the next one is about the normal distribution. The normal distribution is one of the most common statistical distribution, also known as the bell curve. It is it is symmetric with the mean, median, and mode being equal. The feature of the normal distribution is consists of, it is symmetric around the mean. I will actually show you the curve of the normal distribution, that you can see actually you can find and determine the line that show you the mean. I can see you now. This is the mean line, that this is the mean line that actually there are something that happen around of this mean line. It is symmetric around the mean. It's happen symmetric around of the mean. You know, this is the mean plus sigma, or standard deviation, and mean minus sigma. So this symmetric around of the mean. The total area under the curve is 1. Total area under the curve is 1. Okay, total area under the curve is 1. The spread of the curve is determined by the standard deviation, I mean sigma, that I show you. So the normal distribution is used to analyze various data like height, weight, and industrial measurements. For example, suppose you work in a bakery producing cake. Each cake show weight about 500 grams, and the weights follow a normal distribution with a mean is equal 500 grams, and the sigma is equal 5 grams. If a cake's weight is between 495 and 505 grams, it is acceptable. Calculating the probability of producing a cake outside this range using the normal distribution helps identify defective items. A high number of the cake outside the range signals the need to adjust equipment or processes. So I've shown you the curve about the normal distribution. This is very easy, very simple, you know. So the last one is the sigma, Six Sigma. It is very important. Six Sigma is a statistical methodology developed by Motorola in the 1918s. Its goal is to reduce defects to fewer than 3.4 per million opportunities. Oh, it's amazing. Why Six Sigma? The name comes from covering um, plus 6 minus 6 standard deviation from the mean. So this range includes 99.99966% of all data, that making defects almost non-existent. The benefit of the Six Sigma is reducing waste, increasing customer satisfaction, and lowering actually defect related costs. it is it is very important that you know that Six Sigma in the um, operation management. This is showing you the Six Sigma curve. You know, this is the mean line, and this is the, for example, minus 3 sigma standard deviation minus plus 3 standard deviation. This is the minus for the standard deviation. This is the plus for standard deviation. All the information is distributed around of this point, you know, and all the information that happen the under of the curve. So for the Six Sigma, we're gonna have a example. Reducing defects in production. Imagine you work in an electronics manufacturing plant or factory where soldering defects need to be minimized. Before implementing Six Sigma, the defect rate is 2%. I mean 20,000 defects per 1 million units. After implementing Six Sigma, the defect rate is reduced to 0.002%. The defects per 1 million units, practical use 1 million units. The I have a confusing about this. The defect rate is reduced to 0.002%. I mean the 2 defects per 1 million units. Six Sigma optimizes processes to reduce defects and lower production costs. So, guys, now please I want to have some explanation for you. Okay. How these concepts relate in quality management. PFM and PDF help understand data distribution and identify problem areas in processes. You can find that according by some pictures that I show you. about the curves that happen for this kind of information, this kind of measurement. This is very important that the measurement, that the data that is resolved from the PMF and PDF is very important for the Six Sigma method. You know, Six Sigma method use the PMF and PDF and normal distribution for having a good actually having a good measurement about the quality of operation quality. You know, it is very important that the data that actually result from this measurement is persist, and according by this data we can use to the Six Sigma and continue and have a good measurement about the quality of the control. Sorry. The normal distribution, the assesses processes stability and predicts production behavior. Six Sigma reduces defects and improves overall processes performance. So let's wrap up from our presentation and about my explanation. In this session, we learned how to use concepts like normal distribution, probability, and Six Sigma in quality management. These tools help us reduce the defects and improve the quality and enhance the customer experience. So, it turns you should use, for example, many example and many example about this kind of measurements, for example for your own business, and you can use from this kind of measurement for your some examples, and you can improve yourself and you can active your mind for your business, and you can use for your life according by these kind of measurements. Thank you guys. Thank you for your attention. And I'm very excited that you participate for the another of my videos. And please comment me if you have any comments and any recommendation about my presentation. And I hope see you again for the next session. Thank you and have a good time.